Okay, so we will go ahead and get started. Thank you guys so much for joining us. We are so excited to be here. My name is Kristin Luthi, and I work for Gwinnett County Public Schools as an instructional coach. And so I'm an instructional coach over science, elementary school computer science, and then I also support our new AI initiative. And I am joined by my dear friend and colleague.
Hi all, I'm Sallie Holloway. I work with Kristin in Gwinnett. I work in our CTE office supporting 6 through 12 computer science and engineering. And like Kristin, I'm also doing some work to support some AI initiatives that we have in the district. So very excited to be here with you all tonight and learn together.
Yes, and so this presentation is about integrating science, taking those science standards and integrating AI in them. So for this activity, students will be developing a model based on observations to describe a repeating pattern of the phases of the moon. So in 4th grade, they have to know all of the different moon phases. And they're going to do that by using machine learning to train a machine capable of identifying the moon phases from the different models that they're going to create. So here is the standard that goes along with that if you need to plug that into your lesson plans. So they're going to obtain, evaluate, and communicate information to model the effects of position and motion of the Earth and the moon in relation to the sun, specifically understanding and developing a model based on observations to develop a repeating pattern of the phases of the moon. So the activity overview, they're going to actually train a teachable machine to identify the moon phases by creating that model. So for materials, this is actually a great lesson. I know in Gwinnett County we are doing a concurrent model, and then some of our teachers are teaching digital and some of our teachers are teaching in person. So one of my favorite things about this lesson is it can be with any of those models. If you are teaching digitally, if you are teaching concurrently, or you are teaching in person, this really meets the needs of all of those students. So your kiddos are going to need a laptop or a Chromebook. They're going to need the Teachable Machines websites, Google Draw, or paper and markers, okay? So you're going to start off your lesson by having your students look at these two pictures. And then you're going to have them think, what are the physical differences between a cat and a dog? So I'm going to hold the silence for about 30 seconds. And if you will just type in the chat box, what are the physical differences between a cat and a dog? Sallie, will you read off some of our differences?
Got some good ones. We have size, whiskers, personality, bad breath. I'm not sure which one has good breath. Snout, teeth, shape of nose, shape, willingness to keep tongue in mouth.
Yes,
Slobber
definitely.
tongue versus sandpaper tongue. That's a good one.
Perfect.
Those are all good.
Yes, those are great. Thank you for sharing those. And so you're just going to get your kids to start thinking about what are those physical differences between a cat and a dog. Okay. Then you're going to jump on over and model a teachable machine. And I'm going to actually do that for you. But you can see on this picture how it kind of works. You are going to upload some images of cats. You're going to upload some images of dogs. And then you're going to train your machine. Then you can show it a picture, or actually when we were doing this afternoon, it was showing my web camera, and I think it said that I was 100% a dog at one point, but it's a lot of fun to train the machine and then let it differentiate between which is a cat and which is a dog. So I'm going to jump on over to the Teachable Machine website. And you see that it starts with 2 classes. So for the cat and dog activity, class 1 is going to be obviously a cat, and then class 2 is going to be a dog, okay? I have pre-uploaded some images. I've just put them in a folder. So when I click upload, I'm going to click on choose images from your file. And you can see I have some cats and some dogs. So my first category is cats. So I'm going to put in my cats. And obviously we know with big data and AI, the more data that it has, the better it's going to be able to differentiate between a cat and a dog, okay? But we're just gonna start with 3 pictures now. So I've uploaded my 3 pictures of a cat. I'm gonna go down here and I'm gonna upload my pictures of my dogs. So here are my dogs. Okay, so my 2 categories, I have my cats, I have my dogs, and then I'm going to click on train model. And sometimes this takes a few seconds for it to train. So we're going to let it train. There we go. Okay, so you can see that my model is trained. I am in webcam mode right now, so it is trying to figure out, based on my pictures, whether I am a cat or a dog. So it looks like I'm about 60% a cat and about 40% a dog, depending on how I move my face, right?
Which is funny. You're
So
more
yours,
tonight than you were today.
yes, and we figured out that when I had my mask on, it made a difference to whether I was a cat or a dog. Okay, so your kiddos can hold up pictures and show the webcam, and it will determine. Or you can click on this webcam and change it to file, and then you can upload a file. So you'll see in my folder, I have a test. So I'm going to click it, and then it will tell me. It's actually hidden under here whether it is a cat or a dog based on what image I upload. Okay, so it is a lot of fun. The kids get a kick out of it. And it's just a lot of fun to play with. So we are going to take just about 3 minutes. And Sallie is going to put this link in the chat box. And so I'm going to give you, we'll say 3 minutes to kind of play around, upload some pictures, and see if you can train your machine. And then we will make that connection to how this links to science and what that lesson will look like. I do not believe that there are teacher accounts so you can see the students' work because it's really just getting them to train the machine. There is an option, though, to export the model. So you could definitely get them to export the model and share their project with you in whatever Google Classroom or whatever you're using for your kids to turn in work. So we will take about 2 more minutes if you are just now entering to look at that Teachable Machine website. And then we'll make our science connections.
Noticed your dog in that picture is wearing a suit and tie.
And drinking coffee.
That's cute. Oh, Brian. Not too exciting.
And as I was doing this, I was thinking, you know, lots of cats look very similar, but when you start looking at dogs, of course, the more data you give it, the better it's going to be. But there's just, dogs look so different depending on the breed. So definitely getting your kids to upload multiple pictures when we talk about machine learning and AI in our big data. The more data we have, the better the machine is going to be able to learn. So we will go ahead and keep on moving on. I do want to address the export. So if you, where it says preview, you can go to export model, and your students can export their model and show it to you. So you can have them turn it in Google Classroom, but it's just as easy as them clicking that button. Okay. So how are we going to take this machine learning, these teachable machines with cats and dogs, and link that into science? Well, first of all, AI is, or teachable machines is a form of AI, right? So teachable machines is a type of machine learning, which is AI, that is capable of distinguishing images from one another once it has been trained on a number of already identified images. So we are putting in those identified images saying this is a cat, this is a dog, and then we are training the machine in order for it to be able to learn and distinguish, right? So in science, we always like to start off with a phenomenon. So if I was making this connection with my students for fourth grade phases of the moon, after I've taught them a little bit about teachable machines, I would start with this anchor phenomenon and have my students do the notice and wonder protocol. So what do you notice about this? Hopefully they notice that there are different phases of the moon is changing, the moon looks different, okay? And then you're going to want to show your students lots and lots of moon phases. Just like we were talking about with the cats and the dogs, the more the machine learns, the more the machine sees, the better it's going to be at learning and distinguishing between the phases of the moon, okay? So the next step of this, after we've done the notice and wonder protocol with the phenomenon, is to let them look at multiple moon phase diagrams, okay? And with your students, you're going to want to talk about what are the differences? What do you see here? And hopefully they're going to see that some of the diagrams use different sizes. Some of them have different shapes of the actual model, right? Some use different colors. Some use different patterns showing the moon. So really getting kids, like we did with the cats and the dogs, to realize that a moon phase diagram can look many, many different ways. So whenever we go to train our machine on the phases of the moon, we're going to have to show it many, many different types, okay? And then you're going to give your kids this challenge. Can you train a machine that can recognize which phase of the moon it is seeing and name it? So just like we did with cat and dog, can we train it to recognize the different phases of the moon? Okay, so how are they going to do that? Well, they're going to look at the cat and dog example, right? And then you're going to get them either to use Google Draw, or actually they could do it with paper and markers. And they're going to draw at least 5 models varying in color, shape, and size. So going back to those diagrams that we looked at, how can I draw the full moon so that it looks 5 different ways? How can I draw the new moon so that it looks 5 different ways? How can I draw a waxing crescent so that it looks 5 different ways? Okay, so either getting your kids to do that in Google Draw or on a piece of paper. Then you're going to have them download the image files of each model and place them in the appropriate class. So just like I did with the cat and the dog, I'm going to create classes. So this might be a new moon, right? This one might be a full moon. And with 4th graders, I would limit it to probably just 3 or 4 classes to start with. So just so that they can get the idea, okay? So they're going to make their classes, and then they're going to upload their pictures. So these are all of the pictures of the new moon. These are all of the pictures of a full moon. These are all of the pictures of a waxing crescent. And then they're going to train their model so that when they show the teachable machine another picture, it can identify, okay? So that's really getting to the level where the kids have to know the phases so that it can essentially teach the machine how to identify it. So they're going to download their images and they're going to train their machine and then validate your machine with the images given to you, okay? So you're going to give your students different images for it to test. When your students are finished, explain how the machine can tell the moon phases apart from the images you trained it with in the beginning. So in other words, what is the difference about the models? What is different about the models, and getting kids to think out that process. How was the machine able to tell the moon phases apart from one another? Really getting at that distinguished level where they are refining their model and explaining and validating their model, okay? And then did you have any troubleshooting? They might realize that they have drawn a bunch of full moons, right? And the machine is not recognizing the full moon. So how do I need to change my model in order for the machine to be able to learn it? Okay. So giving kids those questions. So other science applications. So you could do this also with types of clouds. In fourth grade, students have to know the different types of clouds. So they could train the teachable machine to differentiate the types of clouds. States of matter, the water cycle, the different phases of the water cycle, precipitation, condensation, and training the teachable machine in order to differentiate between the different parts of a water cycle. Plants and animal cells, right? You could show it a lot of different diagrams of plant cells, a lot of different diagrams of animal cells, and have it differentiate. Chemical and physical changes. We teach those properties of the chemical changes and the physical changes. So students could upload those and teach the machine to differentiate between chemical and physical changes. Properties of soil. They have to know the different types of soil and the properties behind it. So they could teach their machine to identify the different types of soil. That's a third grade standard. Rocks and minerals. What's the difference between a rock and what's the difference between a mineral? Showing the teachable machine multiple pictures of rocks and minerals and then having it differentiate between what is a rock and what is a mineral. So that is also third grade. So we have some fourth grade examples, some fifth grade examples, and some third grade examples. And those are just the ones that I could think of off the top of my head. So I'm sure there are plenty of others. So that is the end of our presentation. We will stick around and answer a few questions, or if you're like me, you want to go and play with the teachable machine and teach it a few things. So Sallie has that link in the chat box. We have also linked our presentation, so if you want to use that with your kiddos, feel free. We would love to hear feedback. If you do use it with your kids, what they thought. So feel free to reach out to us and we would love to hear about it. So Brian, I just Google image searched those. So I went into Google and I searched cat and I just dropped them in a folder. Or you could go to Google Draw and draw some images. Bye, guys. Thanks, Sonia. Hey, Autumn, how are you? I love that, parts of computers. Absolutely. That totally would work. I love that. I think it's really cool too, Hannah. It's my favorite AI. Well, that ends Quick Draw, the Google Quick Draw. Okay, guys, if you don't have any questions or you are not playing with Teachable Machines, feel free to go check out another session. Bye, Natalie. See you tomorrow.
Oh, I know a lot of people are leaving, but I'm going to throw a link in the chat that is to another Teachable Machine activity that actually connects to Scratch. So if anyone wants to check that out, that's a good resource too.
And Natalie just threw in a code.org AI Ocean activity.
Yeah, that's a good one. All right. Thank you to those of you who came. Hopefully you got time to catch maybe the end of the last session, but if not, we'll see you in the closing. You'll have a good night.